Hi Geo 102 Online. A lot of people had a lot of trouble with the fronts question. So if you had trouble with the fronts question, don't feel badly because there were whole groups that couldn't get it. So I'm going to go over it really quickly. But before I do, I just want to make a note. If with one of the diagrams, you may have to draw or interpret a diagram on a test. So if the diagram is stressing you out or taking you too long, then then something is wrong and you need to talk to me. You should be able to draw these diagrams in a few seconds, not have to take, a half an hour of sketching. So I think what the big problem was here was a lot of people were trying to draw the diagrams 3D rather than just do the side view. So I have your book here. Okay, and we're going to look at a couple sets of diagrams. So, and I also have a whiteboard. One of the group members mentioned that she was getting a whiteboard for drawing diagrams for this class, and actually that is a perfect way to go about it. It's a great way to practice. So you could have a flip card and say, I'm going to practice drawing a cold front, and then check your notes and go back and forth. So I'm going to do the side view over here, which is what the question was about, and we're going to do cold fronts and warm fronts, and then I'm going to talk about the map view. So the diagrams that are relevant in this particular question are on, if you have this edition of the book, some people have slightly different editions, it's on page 581, 582, and then when we get to the maps, it's on 584 and 585. So if you're following along in this text, however, all the editions of the book should have the same diagrams in them. So we're going to take a look first at these two diagrams, at the 581 one and the 582. So if you look, let's start with the 582 with the cold front. This is the cold front diagram right here. Now the front view, or the side view is just this front portion of the diagram. It's hard to see with the glare. Let's bring this up a little bit. It's just this front portion of the diagram. Don't worry about anything going back three-dimensionally, okay? We don't worry about 3 dimensions here. So, because I'm not an artist, I mean, you'll see that in my sketches. I'm a terrible artist. So I'm not going to expect you to be able to be an artist. So let's look at that side view of a cold front. So for a cold front, we have a cold air mass with a steep slope like that. This down here is going to represent the ground. Okay, and we will label that cold. And over here we have our warm air mass. And the cold air mass is moving forward. We draw a little arrow like that. Now how is the warm air mass moving? The warm air mass, as the cold air mass moves forward, the warm air mass flows over the top and gets a little bit pushed forward as well. Okay, so why does this happen? Why does the warm air flow over the top when a cold front is moving through? It's because warm air is less dense. It has, density is mass divided by volume. And basically the intuitive meaning of density is, can it float? So warm air is less dense and therefore floats on top of cold air. So when the cold air pushes through, that warm air flows over the top. Now let's take a look at the picture of the warm front. Once again, we're just doing the front portion here. In the warm front, if we have the ground down here, we have this shallow slope like this, because here we have the warm and here we have the cold, and it's the warm air pushing forward. So basically, it's as it pushes forward, it slides over the top of the cold air mass. So we have this warm air sliding over the top of this cold air mass. Now this is the actual boundary line that we see on the ground in the maps. So this line basically goes backwards into the diagram. So it's kind of thinking 3D. Every science has its difficulties. So in chemistry, you have a lot of mathematics and abstract thought. In biology, you have a whole bunch of Latin words to memorize. In geology, the hard part is thinking in 3 dimensions. And that's something that we're going to have to do in several units. But don't be afraid. Give a best shot on your discussion board. And then if, in like a case like this, if there's a bunch of people that don't understand, I'm happy to go through it again. And also, I can make these videos for you individually as well. So don't ever be afraid to ask me for a video. So we have this warm air flowing over the top of the cold air. Okay? And that's a warm front, and up here we have this steep side. Now the important feature here, see how steep this is? It's almost like straight up and down. That's one of the hallmarks of a cold air front. Whereas the side view on the warm air front, it's really shallow. Now let's talk about clouds really quickly with cold and warm air fronts. And I'm just going to use a different color. I'm just picking blue because it shows up against the black. In the cold air front, you get these steep thunderclouds that go over here. Whereas with a warm front, you get these little shallow poofy clouds. Now, you can get rain with a warm front, but it's from nimbostratus clouds, not cumulonimbus clouds. So the nimbostratus clouds are going to have like little light rain that's basically falling down. It's a pleasant like spring shower. Whereas with a cold front, it's those big thunderstorms. And we sometimes see those big thunderstorms happen, particularly in the summertime when we have cold air coming down out of Canada and it hits that warm air that warm air mass, that warm air pocket, and you get a lot of condensation, and boom, you get these thunderstorms with lightning. That's some very poorly drawn lightning. Okay, so that's the side view here, where the blue represents the clouds. Now let's take a look at the top view, also the map views. This is looking down. Now in the 2 maps on page 584 and 585, we both have mid-latitude cyclones, which are these huge convergence of a cold air mass and a warm air mass, and another cool air mass. So if we take a look at this diagram over here, we have a cold air mass, a warm air mass, and a cold air mass. And this cold air is moving faster than this warm air, and it creates this occluded front with this low pressure zone right in here. Okay, so these are massive, massive air mass systems, and they can actually cause smaller storms, such as lake effect snow and tornadoes. So let's look at the cold air front, which is this one, and the warm air front, which is this one. So on a map, a cold air front, and I'm going to use the right colors, I'm going to use blue and red. A cold air front is symbolized on a map looking down as a stripe like this with these little sharp blue teeth. Okay, like that. Whereas a warm front and oh, by the way, just to make it clear, these teeth are pointing in the direction that the cold air mass is moving. So if the teeth are pointing that way, the cold air mass is moving that way. Now with a warm air front, it's usually shown in red, and you get kind of like this scalloped edge like this rounded half circles going all the way around. And once again, the half circles point in the direction that the mass is flowing in. So here you have side view of warm air, a side view of a cold front, and a top view or a map view of a cold front, and a side view of a warm front, and a top view of a warm front. And I think one of the problems is that a lot of people try to mix these two together. You don't need the teeth or the little half circles in the warm front and the cold front in the side view, because you're just looking at it from the side. So I hope that helps. Feel free to PM me or message me or email me at cebey@sunijefferson.edu if you have any additional questions.